some other things that you're still unsure about. Right, so test review. And this is for chapter 3, right? What I will say right off the bat is factoring booklet. And now you're going to be focusing on pages 7 to 8, so it's basically the end, right? Key is online, right? Key online, right, in Google Classroom, so the whole booklet is there. So look for that. And if you want to be very well prepared, I will also give you some textbook questions to try. And basically, I'm going to do this. I'm going to tell you 198 to 200 is where things are found, but I will say omit or skip questions 15 to 18 actually. 20, 22, and 23. And so I'm going to work overtime today so to get you this quiz back, okay? You're going to get this quiz back. And if you wrote it on paper, I'm just going to email it to you, right? And you will get it that way. And then these are some bullets, right? Obviously, prime factorization, factorization. You should know what that means, right? Find the GCF and LCM using the prime factorization, so review that. Find the square root and or cube root, right, of a number. You have to be familiar with expand and simplify. Expanding and simplifying. And then obviously the last one, factoring. I will tell you follow 5 steps, right? Always follow the 5 steps, in particular the first 2. You're like, 5 steps? I'll just cover this up one moment, right? I showed you how to factor fully. These are the 5 steps that if you go through them, you will kind of eliminate, right? You kind of go through it and you might have to stop at 3 and be done with it. But if it's not a PST or a DOS, then you keep going to, is it a trinomial where A is equal to 1? Or is it a trinomial where A is not equal to 1, right? So those are the, and then always watch out for multivariable, which I will talk about today. I will kind of do them side by side, okay? And so just to reiterate, just to summarize, have them all in one place, right? If you have a difference of squares, DOS, right? What is that, right? It's a binomial, right? With a negative between terms. That's first of all, you're looking for a negative, right? Let me just focus once here. That's better. It's a binomial with a negative in between. First and second term are perfect squares, right? If you were to take the square root of them, you get a whole number. That's the variable and the number itself, right? And so what you get is, right, x plus a number, x minus a number, right? And these are both the square root of the first and the last, right? Then how do you check for a PST? Perfect square trinomial, right? How do you check there? First and last are positive and perfect squares. And that's the first thing here. The first and the last are positive and they are perfect squares. The middle term is 2 times square root of first times square root of last. Right? If the middle term, if you want to check, like just the check you have to do is you go 2 times square root of the first, square root of the last, and the square root you will already have performed, right? Because they're perfect squares. You're checking for that anyways. Okay, so that's there. That's the middle term, and what you get is something like this squared. So it's just one bracket where both are the same. And then listen carefully. If you miss the boat on the PST, you don't recognize it, you don't catch it, you can still do the matrix method, right? You'll still do the matrix, and it might take you a little longer. It will still work, but you'll realize, wait a minute, both of my brackets are exactly the same, right? And then you should realize that, oh, I'm going to write it like that. That's convention. It's not like it's wrong if you write the same brackets side by side. But some students they miss the fact that it's a PST, and then it's a little bit more work because you have to do the matrix, right? And then you have 2 more categories, right? A is equal to 1, right? And then you have A is not equal to 1. Here you have to use the C, right? And then you have factors of C, and they have to add up to B, right? That's how you do it that. And then it's called the multiply sum method, right? That's just the easiest one that we started off with. I got you to do the puzzle so you would be quick, right? Add them. And then there's a rule, right? If C is positive, then both of them will have the same sign and it'll be the same sign as B, right? If A is not equal to 1, use matrix method, right? If C is positive, then factors have the same sign as B, right? If C is negative, opposite signs, right? If your factors will have opposite signs no matter what you do. And then I'll just put here, watch out for multivariable polynomials. Okay, steps are the same, comma, but brackets have both in them. That's all I'm going to say for that. Okay, so let's have some examples here. So let's say you get negative 2x squared plus 11x minus 9. And then always make sure you go through the 5 steps, right? The first step, right? Rewrite if necessary. So having the x squared in the front, or the k squared, m squared, whatever. And then take out a GCF. So you're looking, the negative comes out for sure, right? The negative comes out for sure because the leading coefficient is negative. And then you see if there's a common number you can take out, and that you can't in this case, right? So it's just negative 2x squared minus 11x, right? It changes the sign of every single term in there. Okay. And then I will do my matrix underneath because I will do a side-by-side comparison. Okay, so I will do my matrix here, and it's 1, 2. And notice that C is positive, so both of my factors of C will have the same sign as B. I know that already. So you can try 3 and 3, right? Or what times 9? So they both are negative. So you try that, right? That gives you negative 6. This gives you negative 3, and that adds up to negative 9. It doesn't work, right? It's not going to work out for you. So I'm trying again 1, 2. And I'm going to try 1, 9. And you get, right, they both have negative. So that's negative 9. And that is negative 2. Then I add it up. It's negative 11. That's exactly what I need. Oh, I should have one step back, right? This a is not equal to 1, right? One step back here should have been like, okay, a is not equal to 1. I can't just do the simple multiply sum method. Okay, and then once you figured this out, that this is the one that's going to work for you, make sure, I told you this already, right? I promise to never forget the negative in front of the bracket, right? Because it happens too often, right? So then you go, this first one is the coefficient in front of the variable, and then the second one is the number, right? And then the second pair here, this is the one that goes in front of your variable, and the second one is just a number. And this is factored out. Check, negative 2x, right? Negative 9x adds up to negative 11x. I'm good, right? So I would like to have a side-by-side comparison, right? So I'm going to use the exact same one that I have here, but I'm going to put a little twist on it. I'm going to make that a multivariable question, right? Sorry, this has to be squared. This has to be squared, right? Let's go through the motions here, through the steps. Do I need to rewrite this? No, because you have two variables, right? The squares are on either end, leave it, right? Do I need to take out a GCF? Negative is technically a GCF, right? It's also under that umbrella. I can take out a negative, right? So I'm left with this plus 9y squared. Now, let's hold on here. Let's say you're writing a test. You're like, wait a minute, is this maybe a PST? It's definitely not a DOS, right? It's not a difference of squares out the window, right? Because there's more than 2 terms. Is this a PST? I see some shaking heads. Like, no. How come? Well, this is, right, you can take the square root of 9. First of all, first and last term are positive, okay? This one you can take the square root of, it's 3y, but you cannot take the square root of 2, so PST is out the window, okay? I didn't go through that here, but it's basically the same question, it's just this is a multivariable. So I will spare ourselves this step. I will just rewrite it, right? So I will say, we basically use the same matrix here, but it's going to be like this, watch. It's going to be x minus, what's my second variable? Y. So it's 1 goes in front of the x and the negative 1 goes in front of the y. So it's this, right? See how that turns? And then my second pair is 2x minus 9y. So if you notice the difference between, right, our two answers, they're essentially the same. We still use the same matrix, but because there is a second variable, right, we need to make sure we have that taken care of, right? Because of this, we had to have this there, okay? So this is a side-by-side comparison, single variable, multivariable, right? And I just shortened variable there, but that's how it works. Another example. How are we doing time-wise? Yeah, 24 minutes. Yeah, we're doing okay. We're good? Okay. Okay. Let's go with negative 50 m squared plus 2. Do I need to rewrite? Technically, no, right? Because the squared term is up front. So don't rewrite. I need to take out that negative, right? So let's do that. Negative. Can I take out more than just a negative? You can take out a 2, right? They're both even. So this gives me 25m squared. And the positive 2 divided by negative 2, that's negative 1. So you've taken out the negative, you've taken out the GCF. You're left with just two terms and there's a negative. So you have to ask yourself, is this a DOS? Is this a DOS or what? Right? Well, let's check. You take 25m squared, that is 5m. So that turns out. And then you take the square root of 1, which is just 1. So it is a difference of squares. It is a difference of squares. So then you go negative 2 and you use the square roots here that you found. Okay, that's important. So it's 5m plus 1 and then it's 5m minus 1. And you're done. So I can tell you this, a PST and a DOS is a 1 mark. Okay, except for if you have to take something out. If you have to take something out, then it's like there's going to be a half, 1.5. It's like, oh, wait a minute, Mr. Jackson is giving a half mark for something here. I don't know what it is. Oh, yeah, it's probably a GCF, right? So there it is. What if it's a multivariable? Let's make this a multivariable question, right? So we're going to go negative 50 m squared plus 2n squared, like that. Same question, same coefficients, it's just like I made it a multivariable, okay? So I take out a negative. Some of you might say, well, can't I just rewrite it, Mr. Derson? Can I just bring this? When you know it's only two terms, I would just take out the negative and that's that. So I can also take out a 2. So that's 25 m squared positive minus 2 divided by negative 2 is negative 1, and then you're just left with the n squared. Okay, and that we already know is going to be negative 2. Is this a difference of squares? Well, 25m squared, if you take the square root of that, that's 5m. If you take the square root of n squared, that's just n. So it's a DOS, right? So these are the two terms that I'm going to be using in my difference of squares. So 5m plus n, 5m minus n. I will just make sure you understand that you could have another difference of squares here if but then you would have to have m to the 4, n to the 4, right? You would have to have the variables to the power of 4 for that to be a case, okay? Let's do, and I know I might be going a little fast at home, okay? But I'm recording all of this. So if you need to have another look at it, we'll do so. And I'm really gonna shake this one up here. Let's see. Do I need to rewrite this? K squared is up front. We're good, right? Nothing there. Do they all have maybe the same variable, right? Like sometimes you have k cubed, k squared, k, right? We can't factor cubes, right? Like the way we're doing that. So then you'll have to take out that common variable. But they're all even, so I know that 2 goes into all of them for sure. So I'm going to take out the 2. Because before you can identify if it's a perfect square or whatever, you need to take out common factors and then you'll be able to see it. So 2 goes into 16 8 times, goes into 2 1 time, so it's 81k squared minus 72k plus 16. Okay, so you've halved everything up here. And DOS is out of the window, but you're checking, is this a PST? Is it a perfect square trinomial? Let's check. They're both positive, so that passes the test. The middle term is even. I forgot to mention that, but the middle term has to be even or else out the window, okay? Right away. It's not going to be a PST. So it's 81k squared. So 81k squared is going to be 9k, right? And then I take the square root of 16, and that is 4. So this passes the test. One last test now, mid. Who called me on it? Was it somebody in here yesterday? The example, yeah, was it you? Is it Rowan? Yeah, okay. He caught me on it. I was just like making it up on the fly when I was giving you the notes, and he caught that mistake. So good on you there. Anyways, the middle term is 2 times the square root of the first, which is 9k, times 4. Right? So 2 times 9k times 4. And you do the math here, right? If you want to go 9 times 4 is 36, times 2 is 72. It is 72k, which is what our middle term is. Don't worry about the sign, right? The sign will come in soon. So you've done your checks. No need to do a matrix. So we'll just go like this. Negative 2. Oh, sorry, 2 positive, no negative. Is going to be 9k. This sign tells you what goes in here. Right? This sign is what goes in here. And then you take the second term like that and you square it. It's a perfect square trinomial. So the sign is always dictated by this. If this had been a positive, this would have been a positive, right? And you can always FOIL it out if you have time. No matrix needed. Okay? What if it's a multivariable? You're sick of multivariables probably, right? I know, me too. But you need to see it just in case. 144 KT plus 32 t squared. I hope you know that I'm just borrowing from what we've already done, right? Because then you can see the pattern. Multivariable, right? Same as before, but it's multivariable. So how is this going to be different? We're just going to go 2, and then it's 9k minus 4t squared. One last question here. Yeah, this is going to have all components in it. So just in case we run out of time, I already gave you what you're supposed to do for review. So you know what to work on. I want you to give this a shot right now. So I'm not going to give you a whole lot of time. So let's go with 5 minutes. That's going to take us to 10:12. Give this a shot. See if you can do this right now on your own, and then that'll be the last thing we do before I send you off. Rewrite GCF and or negative, right? That's going to be my first step here. Negative 12y squared plus 34y minus 10. I can take out a negative for sure, and they're all even. 2 goes into all of them. So that leaves me with 6y squared positive, negative 17y plus 5. Okay. And I try my matrix here, right? I notice that a is not equal to 1. This is not a PST guaranteed, right? You know that 6 doesn't work, 5 doesn't work. PST is out the window. So I'm going to have to do the matrix. Okay. So we try 2 and 3. And then it's 1 and 5, right? 5 doesn't have many options. So sometimes when C doesn't have many options, A will have, right? So A has 1 times 6 or 2 times 3. So you try one that you think might work first, and then you go with it. So 1 and 5, and I know this is positive, so both factors are going to have the same sign as B. So be careful because it won't always be the case, right? So in this case, I know they're both negative. I try this, I get negative 10. I try this, I get negative 3. That doesn't get me there, right? Negative 13 doesn't work. So I tried 2, 3. I'm going to flip them. Negative 5, negative 1. I get negative 15 here, and I get negative 2 there. That's negative 17. That checks out, right? You might have tried 1 and 6. But remember, there's only one way that works. Okay, there's not more than one way. There's only one way that works. So you must find that one. Okay. So then I use this as my matrix, right? 2, -5. So it'll be 2, in this case, don't mix up the variables, okay? We're dealing with y, -5. And then it's 3y minus 1. And you just do a quick check, -15y, -2y, that's -17y. Checks out, right? Still have 7 minutes. You might think, no, I don't want more, I'm good. Anyways, just watch the video of the quiz correction if you want more, because there will be the expand and simplify and the cube roots and all of that will be on there. So I will call it a day here. Have a great weekend, guys.